Okay, so with this one it says state and write the transformation from the parent function. So looking at this, our parent function would have been f of x is equal to the absolute value of x, right? That's the parent function, non-shifted function. So it looks like we're going to right 3. How many got that part right? Awesome. And then we're going up 4. That's the shift. So we're going to right 3 up 4. There's our new starting point. There's our vertex. Then the next thing is, what's your slope? Isn't it 1 in this one? So our slope is 1 over 1. So we're going up 1 over 1, up 1 over 1. Up 1 over 1. So sharp V. We know that these kind of functions are sharp V's. So then we can draw in our V. How many got it right? Awesome. Okay, let's do domain and range. Now, first of all, is this a stretch or compression?
Stretch.
Actually, neither, right? Isn't A1?
Yeah.
Isn't A1 in the parent function? So it would be neither. Neither stretch or compression. If A is greater than 1, it's a stretch. If A is less than 1, it compresses it down. If it's 1, it's nothing. All right, so then from there, the domain is x values. We're going from left to right. What is it? Good. Negative infinity to positive infinity are all real numbers. Our range is our y values. The lowest y value, not y-intercept. We're talking y value. Lowest y value. Starts at 4 and grows to positive infinity. It started right down at 4. We put a bracket parenthesis. Okay, do today's lesson. So we're skipping a couple lessons because we need full days to the lessons after 7-3. Today's won't take, I need a full day to do the other ones. So this one would be better to learn on a short day, so we're kind of skipping up to this. So today we're doing 7-6. We're going to be combining functions. This is such a huge lesson. It's actually not super hard, but it's a huge lesson. You will see it again in secondary 3 for sure. And you'll just see it on a more advanced level, but really honestly, you'll be ready for next year. Like, you'll have seen this. So what we're doing is combining functions. Another way of wording it is called function operations. So we're going to be given multiple different functions, and given those functions, you can perform an operation on the functions. Now, what I mean by operation is you can add them, addition's an operation, you can subtract the function, subtraction's an operation, you can multiply them or divide them. These are all just operations of functions. So if we're given two functions, such as f of x and g of x, those are two different functions, right, everybody? Yeah. We can add those functions, right? So we can perform addition on them. Now, it's just getting used to the notation that's a little bit different today. So you can see it written like this, f plus g of x. Well, what we're doing, what that really means is we have a function f of x, we have a function g of x, and we're adding those functions. Does everybody see how we're adding? So we can split it apart and just rewrite it as f of x plus g of x. So this means the same thing as this. It's just, isn't f of x plus g of x pretty easy? Won't we just add the two functions together? So it's just getting used to new notation today. You can also subtract functions. It will be written like this, f minus g of x. So this means we have a function of x, we have a g function of x, we're subtracting those functions. So it was f of x minus g of x. So you can rewrite it as this, and then we know how to subtract functions. That's really easy. Well, with subtraction, we've got to be careful. Then multiplication, f times g of x. That means we have a function f of x, we have a function g of x. We're multiplying the function, so we can split it apart and write it as f of x times g of x. So we know how to multiply two functions. We can do that. Division, f divided by g of x. So we can split it apart. That's the same thing as f of x divided by g of x. So nothing super hard, but just getting used to notation. Yes. Okay, so here we go. First example. It says, find the sum or difference. So we're given f of x is equal to x minus 5. We're given g of x is equal to x plus 2. Don't we just have two different functions here? So now we're asked to find f plus g of x. Now looking at it, we would say, oh, I know that simply means f of x plus g of x. So you're taking your function f of x, you're adding it to your function g of x. Well, isn't f of x just x minus 5? So really we have x minus 5 plus g of x plus x plus 2, right? Does everybody see how that's just f of x plus g of x? Now with addition, we don't have to be careful of anything. We're simply adding like terms. So we're combining like terms with addition. X plus x is 2x. Negative 5 plus 2 is negative 3. And that's f plus g of x. So f plus g of x was equal to x 2x minus 3. So not anything hard, it's just getting used to new notation here. Okay, next one. So given the two functions f of x, g of x, find g minus f of x. So you do have to ask yourself, what am I being asked here? Well, we can rewrite this as g of x, that's what came first, minus f of x. Questions on how I rewrote that? Now we know g of x is x plus 2, right? So we have x plus 2, I'm going to put it in parentheses, minus f of x. So minus x minus 5. Does everybody see it? And I put it in parentheses because with subtraction we have to be careful, right, everybody? Questions on how I did that, or like where I put what, or where I'm getting any of this, anything. Okay. So now with subtraction, we've got to be careful, because we know that's technically a -1. Let's distribute it through. So we're going to be dealing with negative x and positive 5, right? Now don't double dip. People will say, so we're minusing that. No, we just distributed the negative so we don't have to deal with this anymore. So now we're simply combining like terms. X plus negative x, right? 0. 2 plus 5 is, so 0 plus 7 is 7. Our answer is 7. So g minus f of x was equal to 7. Questions on that? Okay, let's do another one. F plus g of x. So given these two functions, we're going to find f plus g of x. So we know that that means simply f of x plus g of x. So that would be x squared minus 2. That's f of x. We're adding g of x. With addition, we don't have to be that careful, so I'm not going to use parentheses. Combine like terms. Put it in standard form. X squared, can we add anything with that? Nope, so we have an x squared. Then we have a 3x, anything to add with 3x? Nope. So we have plus 3x, and then we have our minus 2. Nothing to add with any of those. So that is f plus g of x. Okay, next one. Yes. Yes, good question. It would need to be in standard form. So f minus g of x. F minus g of x. So once again, now looking carefully at this one, because it would be different to say g minus f. This one's f minus g. So just rewrite it. I know that's f of x minus g of x. We know f of x is x squared minus 2. So x squared minus 2. Now with subtraction, I like to put things in parentheses. So minus g of x. So minus 3x. So then from there, we're just going to combine like terms, but we'll make sure to distribute the negative through. But isn't negative 3x simply negative 3x? Okay, so now x squared. Any other x squareds? Nope. Then we have negative 3x. No other 3x's, no other x's, so we have minus 3x. And then we have minus 2. Now it's in standard form. We've combined all like terms, so there was nothing to combine. But if there was, we could combine them, right? And we're just subtracting functions here. Okay, questions? Okay. Now, you are going to see stuff like this. So given two functions, find f plus g of 2. So notice instead of an x, there's a 2 there. Does everybody see that? There's a couple different ways you can do this. Personally, I think the easiest is to find f plus g of x, then plug in 2. Because if we have like, what's my function at 1? Don't you just plug 1 into the function wherever there's an x? Well, let's just forget the 2 for a second. Let's do f plus g of x. And then we'll plug in 2 in the end. So f plus g of x. So we know f of x plus g of x. That's what we're going to do first. So that would be 2x minus 1 plus 4x. Right? Plus g of x. Does everybody see how I'm doing this? Combining like terms, 2x plus 4x is 6x. And then we have minus 1. So f plus g of x is 6x minus 1. Well, now we want to know what's the function f plus g at 2. So aren't we just plugging in 2 wherever there's an x? So we'll take 6 times 2 minus 1. So we will have 8 minus 1, which is 7. So our final answer will be 7. F plus g of 2 is 7. Yes. Yes, not adding. Yep, I messed that one up. Not really thinking. 12 minus 1. 11. Questions? Okay. So our final answer, f plus g of 2 is 11. Okay, so let's do this one. G minus f of negative 3. So we're taking g minus f, and then we're putting in negative 3, right? So I'm just going to focus on doing g minus f first. So that's g of x minus f of x. So now we're putting in g of x. G of x is x minus 4. So we have x minus 4 minus f of x. So I'm going to put it in parentheses. Minus 2x minus 1. Does everybody see how I just put it in? With subtraction, we've got to be careful. So really, we have a negative 1 here. So we have negative 2x and then plus 1. Now don't double dip because we just took care of that. So don't double dip. That's gone. Now we're just combining like terms. X minus 2x. X minus 2x.
Negative x.
Negative x. Negative 4 plus 1. Negative 3. Is everybody comfortable with that? That's g minus f of x. But now we want g minus f of negative 3. So aren't we plugging in negative 3 wherever there's an x? So we're going to have, now very careful, because wherever there's an x, I'm substituting in negative 3. So won't I have, I'm going to give myself some room so I can stay underneath it so we can keep looking at that. So very carefully, this is a negative in front, right? So we have negative, anytime you're substituting in something, you've got to put parentheses. So we have negative 3. We're substituting in that negative 3 for x, minus 3. Does everybody see how I made the substitution? Now let's simplify it correctly. What's negative 3? What's negative 1 times negative 3?
3.
So we have 3 minus 3, which is 0. So our final answer of g minus f of negative 3 was equal to 0. You okay with how to do these? Okay? Okay, let's go to multiplication here. So we have f of x is x minus 5, g of x is 4x. We're going to find f times g of x. So isn't that just f of x times by g of x? Everybody? So anytime we are multiplying, we do need to put these in parentheses. So f of x is x minus 5. We're multiplying that to g of x, so g of x is 4x. So we're multiplying all of this with all of this. So in this one, are we going to double distribute? So multiply each term with each term. 4x times x is?
4x.
Good. And then 4x times negative 5.
Negative 20.
Yep, good. Negative 20x. And are we done? Yes. That's f times g of x, right? Yes.
Can you take a 4 out?
If we factor it back out, we'll end up back here, right? These are linear factors. Good question, right? These are the linear factors, so if we factor it, we'll end up back up here. Because factoring is the opposite of multiplication, right? Yeah. There's nothing more to simplify. We can't combine those, right? Nothing more to simplify here. Are you asking if we need to solve it? Because we wouldn't solve it. We weren't asked to solve it. We were just doing f times g of x. Okay. So now it says find f times g of 1. Well, didn't we just do f times g of x? So when we just plug in 1? Yeah? Okay. So we have 4 times 1 squared, plugging in 1 wherever there's an x, minus 20 times 1. So simplify it correctly. Do not take the 4, put it in, and then square it. 4 is not squared, guys. So don't put the 4 in and square it. Does that make sense? We're getting better at not making little errors like that. So 4 times 1 squared, if you need to type it in your calculator, minus 20 times 1, type it in just like that. You get negative 16. Questions? Okay, we're getting down to the end here, and then I'll hand out the worksheet. Given f of x is equal to 2x plus 3, given g of x is equal to negative 2x, we're going to take g divided by f of x. So g divided by f of x. We're really just doing g of x divided by f of x, right? So what goes on top? G of x. So negative 2. What goes in, bottom is f of x, so that's 2x plus 3. Pretty easy, right? That is g divided by f of x. Now we're going to have to find g divided by f of negative 2. We just did g divided by f of x, so let's just plug in negative 2 wherever there's an x. So we'll have -2 times, we're substituting in 2 wherever there's an x. Anytime you make a substitution, use parentheses. Divided by 2 times -2 plus 3. Simplify it correctly. Don't just type stuff into your calculator. Simplify the top, simplify the bottom. On top we have 4. On bottom we have -4 plus 3, right? -1. What's 4 divided by -1? So our final answer, g divided by f of -2 is -4. Question 1 now. Yes.
Doesn't matter what order this g getting f on, or just
It does matter. So if this would have been f divided by g, this would have been on top. Does that make sense? Yeah. So you will pay attention to the order. Great question. Okay. Couple more. So we have f of x is equal to 2x plus 1. G of x is equal to 3 minus 4x. The reason I want to show you this one is because we're dealing with something a little different. So f plus g of -1. So we know that we're doing f of x plus g of x, right, everybody? F of x plus g of x, right? So that would be 2x plus 1 plus g of x, which is 3 minus 4x. We don't have to be careful. It's addition. There's no distributing of negatives. Simply combine like terms. 2 raised to the x power. Anything we can combine with that? No. So we have a 2 to the x power. Okay. And then we have a minus 4x if we're putting it in standard form. Nothing to combine with that, right? So we have minus 4x. And then we do have a plus 1 plus 3. So that's a plus 4. That is f plus g of x. But now we're plugging in f plus g of -1. So we're plugging in -1. So we have 2 to the -1 minus 4 times -1 plus 4. Does everybody see how I'm just substituting in -1? Type it in your calculator. 2 raised to the parentheses -1 minus 4 times -1 plus 4. You get 8.5. There's our final answer. We could put it back in fraction, which is 17/2. Doesn't hurt to put both answers. Okay, are you guys good with adding, or do you need to see one with multiplication of something like this? You would know how to multiply that with something. You're sure? You're sure?
no.
Yes or no?
No.
Do you want to see this last example before I hand out the worksheet? Okay, f times g of 1. So we're taking f of x times g of x. So that would be, anytime we're multiplying, we need parentheses. 2x minus 2 times g of x, which is -3x. Now we would distribute, right? To each term. So careful with this one. We have -3x times 2 to the x. A lot of people think you'll multiply the 2 with the 3. Incorrect. You won't. This is a base 2. Base 2. So you can't multiply it with this. So we're going to have simply -3x times by 2 raised to the x power. You can't put those together. Does that make sense, everybody? And then we have this times this, which you can't put those together. That would be positive 6x. So there we have that. We have f times g of 1. F times g of x, and now we'll plug in 1. So we'll have -3 times 1 times 2 raised to the 1 plus 6 times 1. I'm plugging in 1. So you'll type it into your calculator. -3 times 1 times 2 raised to the first, and then plus 6 times 1. You get 0. So that would be our answer. Okay. All right, I'll hand out the worksheet. Check with me when you have some answer.